Today I am going to talk on JEP 425. This JEP related to the virtual thread, and this virtual thread concept was released in latest Java version JDK19. Note that this Java virtual threads, the concepts are models are included in JDK19 as a preview feature. Please be noted, all the concepts which I'm going to discuss about the virtual threads, generally these are the preview feature. So surely preview feature means this JDK just added in the main release and want uh, someone going to use and give some feedback and suggestion. According to suggestion might be needed in next release or coming release, some concept or some the different syntax semantic can be changed. So general recommendation, just we are going to discuss about the main concept, how these virtual threads are implemented, and once this feature come as a main feature, release feature, surely then anyone of can going to use in the production. But as of now, this is the preview feature, and later release surely this virtual thread concept come in the main part of your JDK. So this JDK19 was released in the just last month September, and just I go through give you the some brief summary what is the virtual threads and what how now Java we can create virtual threads, a different methodology, different way which we are going to discuss. So first I am going to discuss about the what is virtual threads. You already know, since Java beginning, Java is the multi-threaded programming language. Even single line of code you are going to run in a Java, that is run in the main thread. And Java support you can run multiple threads. So this is the new concept of the virtual threads. Why? What the reason behind that? So first things we have to understand about the existing threads. Some are known as classical threads or sometime known as platform threads. So platform threads are the threads, are Java threads, are the threads that are directly bound to your operating systems. Means कि whenever as a Java programmer we say I want to create one thread. So Java virtual machine, yeah, JVM is not going to create any thread for you, but they are just associated one native OS thread. And as you know, operating systems threads are costly. They take some memory and the number of your cores according to the you create. So in way you can say threads or the platform threads are somehow heavy and costly, cost consuming concepts. So here virtual threads say कि we are going to create more lightweight threads. So virtual threads also nothing new, but virtual threads also just lightweight threads. And so first question, sometime maybe beginner, threads is the unit of concurrency, a piece of sequential code that run concurrently with independent of other units. What do you mean by that? We have a set of codes you want run as a concurrently. So that is the basic concept of threads. So threads are limited, means कि whatever the current Java offer you can create, you have a limitation. You can create limited number of threads, might be related to your hardware capacity and plus your number of cores which you have. So due to this limitation, JEP 425 say कि we are going to support kind of not the platform threads but kind of virtual threads, and virtual threads enable thread per request style, means कि for each request now our application can create a thread. That means previously you have a limited number of threads, limited number of, we cannot create the thousands or millions of threads, but requests can come. So due to that limitation, here the concept JDK say we are going to support virtual thread concept. So the main purpose of this virtual threads, so that key now in Java applications or any application server can create many number of threads as needed. Don't bound I am running on the particular operating system, so they have a limitation. No. So the number of threads is limited because Java threads is the operating system threads. That means ki whatever the current JDK offer you to create the threads, that is by default your platform threads. Means ki whenever you create, I requesting Java create one threads, they are created for one, but they are bound to one specific operating system threads. And so this new thread like a virtual thread also nothing. Virtual threads is threads, that is simply instance of your Java thread, but it is not bound to the particular operating system threads. So what do you means that? Let us example. If first let's some write example. How previously we write threads. Sometime there is a th thread class and equal to new thread and thread dot start, and you have a one task runnable task plus thread name. So previously you define your task, that means which sequential code you want to run as a thread, and after runnable task, your task you want to just pass your object to the thread class, and now your thread start, and after that thread start join, so that your thread is completed. That's exception. Handle this and run it. So in this way generally this one thread is created for you and corresponding one job associated. So previously these threads are created from your created for like this is the thread number 23, this is operating system threads, and we have a one task, and this task are bound to your this thread, and these threads are your OS thread. So this is tight coupling between your threads and task. Your task is always bound to this thread only. Let's say your task is going to wait for some time. If your task is waiting, this thread is also waiting for you. Once this task is resumed, then these threads are going to resume. But this is your operating system threads. So in the operating system threads, whenever our JVM say ki I want to create one thread, JVM request OS give me one operating system threads, and operating system thread takes some memory like 2 MB memory for your all the call stacks and each and every things and corresponding your task. And once your until your thread is not your task is not completed, your threads are bound to that. And even here you can create the number of thread, and after certain times, whatever the my laptops have a space or core, beyond you cannot create the threads, right? So let us example, I am going here say thread.sleep. Let's keep our half second, 1 second. Okay, so now here your task is just waiting for one particular minute. Okay, and you notice कि our task 1 is started by the particular threads and we are waiting. Still our task is waiting, but corresponding our main thread is also waiting. Let's make a 2 second and just run. So here what I am trying to convey in the existing Java thread model is your operating system platform threads are bound to your runnable task. This task always run on the same threads, right? And this the number of threads you can create also limited. So here it's not possible कि let's give we wait for some period of times and this different thread will take a task. No. So question is that are any way where we as a Java language, Java operating system support, you can create as number of threads as your application needed. Let's my per request. So previous that was the limitation. Due to that कि all the threads which we are creating that are your platform threads. Due to the platform, due to their operating system limitations, we cannot create as many number of threads as we want. We are limited because for each thread only one task is bound. Only one task is bound. This task, once we bound to one thread, this is specific to that. So what the new model in the virtual thread say? So let's this is it possible the threads which are currently associated to this T1 threads, let's this task is waiting. Why not this task is just out somewhere and this thread is free for another work? So now current designs of Java virtual threads, there is no any specific differences. Only difference is we can create your runnable task, that task and that these threads. Previously they are tightly bound to each other. Means ki this thread whatever you creating, this thread always run only one specific task. Okay, so in the new model say this thread can run any number of runnable, not only one. So question is that if you pass only one task, they always run only one runnable task. So how will do? So here the concept is whenever your current running task, this current running task, if they are going to the for sleep or some for IO operation or for some database call or some web service call, some network calls, at that time your task is waiting for the response from the networks. At that time, can we push out this complete task from this thread and thread free for running executing another threads, another runnable task? Yes. So that is the concept implemented by the virtual thread. Virtual thread is nothing, same concept, but only allow your operating system thread are not going to wait for your task. If your task is going for a particular IO operation, they are waiting. Those tasks is pushed out from the threads. And now these threads are free to take another task. So that is the major enhancement in a Java threading model. Now your operating system threads are executing any number of tasks, but if your task is waiting for some time, this task is pushed out and now this thread is ready to take another task. So in this way we are trying to say one operating systems thread can run any number of your runnable tasks. That is any number of runnable tasks here known as a virtual thread. The virtual thread is just runnable task which are can run any available threads. This is separation. Your thread and tasks are separately. Due to that, this no key virtual threads. So here the same things trying to say. Your virtual thread is the instance of thread same as previously, but it is not tied to your particular operating system threads. And the platform thread is the instance of thread that is implemented by OS thread. So our currently whatever the way we are creating a thread that is also considered a classical threads or a platform threads. So you can say virtual thread consume operating system thread only while it performing some calculation on the CPU. So virtual threads are list of threads, but they are going to consume or use your operating system threads when they are really need to do perform some calculation some on the CPU. Else they always in the out of thread. Okay, so these are the major JEP25 demarcation. Whatever the in existing threads we are doing, now just separating your operating system thread with your Java threads are runnable task. Both are previously tightly coupled. Due to this tightly coupled, your task is waiting, your thread is waiting. And now if your task is waiting, your thread is not waiting. Your task is just push out from this thread and put in the main memory, a heap memory, and another task we can assign here. And now in this way, one thread can run any number of virtual thread. Means ki one operating system thread can run any number of your virtual thread. Virtual thread just like your runnable task. Okay, so some like here virtual threads are simply threads that are cheap to create and almost anything number of create, because whenever you are creating virtual thread, this is your Java threads, not your operating system thread. And in the JVM or JDK you can create any number of threads, because you are for creating virtual threads you are not demanding directly give me your operating system threads. When your code going to need CPU, at that time your virtual threads are going to the bound on a particular platform threads. And the virtual threads is the very light and a short lived, and due to that there is a previously due to the costly of third creation and management life cycle, we generally recommend ki we always create the pool of thread, so that key thread creation and destroying and managing life cycle of thread, it will also the costly operation. So before this Java virtual thread concept, we generally pool the created thread so that you just reuse the same thread, reuse the same thread. But after this, due to the virtual thread concept, there is no need of pooling your thread, because now you are creating a JDK thread, not the OS thread, and JDK threads have any number of threads you can create, because these threads are not directly bound, not requested to create your operating system threads. And if you talk about the platform threads, means that is the heavyweight and expensive, thus often this is a pull request, and they are long lived and have a deep call stacks and maybe share among the many tasks. So the major demarcation between your virtual threads and your classical threads, or you can say platform threads. So from this concept, generally now say whatever the previously thread says only thread, but now we are going to say the one is the platform thread, another is a virtual threads. The two terminology they are now we are discussing. One is the platform thread, means the operating system threads, and another is a virtual thread, that means your JDK created threads. Okay, a good thing, the stack of virtual threads are stored in your garbage collected heap, and that can be grow and sync as your application run, because the whatever the virtual thread we are creating, that's are stored in your heap, and once they need the CPU, at that times they are pick up from the heap memory, uh, those stacks, and bound to a specific OS thread, and OS thread perform still, they need to wait something, just push out and again store in their heap. And if talk about the platform thread, every whenever you create the instance of java.lang thread, by default this our thread API JDK implemented thread as a OS. The platform threads run on the Java code underlying the operating system and capture OS threads of a entire code lifecycle. A number of platform thread limited to the your number of operating system thread, means in which operating systems you are running Java application, your number of threads is only you can create as your operating system support. But as a Java, since it started with a multi-threading concept, so in Java if you want to create a platform thread, so whatever you are creating any thread like a new threads, these are the by default created your platform threads, means ki they are corresponding your task, they created one OS threads. So question, how we can create virtual threads? Okay, so virtual threads is also kind of instance of your thread class, but that run Java code on underlying operating system, but does not capture their operating system's entire code life cycle. That means you can create your virtual threads, and when the virtual code is needed your CPU calculation, at that time they are bound to your operating system threads, and our life cycle is maintained. If our virtual threads need some waiting or IO operation, they push out from those OS threads, and OS thread is again ready to take another virtual threads. That means many virtual thread you can run on their Java code and the same operating system, and effectively we can say your one platform threads are shared across the multiple virtual threads. You know, our CPU speed and power is so high. Generally one threads, if we are writing to say, so quickly they calculate, and due to the some majorly we our application are in wait state for input, for database call, for file log, for web service call, for network call. During that time our operating systems threads are just waiting, we are just de-utilizing, we are not effectively utilizing our hardware. But now due to this virtual thread concept, we are not wasting our CPU thread time, OS thread time. Now our OS thread is ready to run any number of virtual threads. So virtual threads are lightweight implemented thread and provided by the JDK rather than your operating system. You can say virtual thread is a super lightweight thread, and that is provided by JDK, not the operating system. But surely your JDK threads are not independently. Your JDK or JVM always run on a virtual operating system OS thread. So while running, while executing, they are going to bound to a specific OS thread. Due to the JDK threads, you can create any number of threads, and even you don't need a pooling those threads. So these are the some theory behind that. And if you talk how as this JDK19 release you can create a virtual threads or platform thread, how start. Previously we have only mechanisms to create thread, just start runnable task and create thread object and start. This constructor of thread always create a native OS thread. So this is the by default say this is the platform thread. So what JDK19 have do, they have modified the existing thread class and given some static method, like you want to create a virtual thread or you want to create a platform thread. Be specify. If you want to create a platform thread, just use off platform threads, or if you want a virtual thread, create a virtual threads. And even we have a sometime I want to create thread, and after that we are going to start. Another we have a static method like start virtual thread. That means ki just pass your enable task whatever you have and automatically started as well as. Even if particular thread is running and you want to know if this is the virtual thread or platform thing, this is the one also new functions methods are added. Thread dot is virtual threads. So these virtual threads are platform threads. Java is not introducing any new classes. Whatever the existing our thread class, in this class they are added the concept of your of virtual thread or of platform thread. Even you notice key, and since Java 5 we have options key, even we are generally not going to create manually new threads, but we use the executor service. Executor service is responsible to create a thread and manage the life cycle, and just our responsibility we create a runnable task and submit in their executor service, like executors are like a new fixed thread pool, and let's say I want to create a 5 thread. And you say executors submit dot submit, and here you pass your runnable task. So generally, or manually you can create new threads and pass your enable, or we are generally using the executor service. Executor service create the your threads and just pass the enable. And in this way, generally we are doing the thread creation and lifecycle management. So whatever the thread internally this executor service created, they also created as a platform threads. Okay. So for both way, now you can create the virtual thread as well as. So if you want to use in executor service, executor will also have a new virtual thread task executor. So in the both mode, or thread class or even executors, you have a get the new methods where you can create a virtual thread. Virtual thread means you are creating a thread, but your thread is not directly bound to your operating systems. When your application really need CPU, at that time your virtual threads can pin to your operating system thread and operating system going to execute. Once your thread or task going to forward something, just again unpin. So here words sometime whenever you do the official documentation of JDK, they words use the mount and unmount. So this is your threads, OS threads, okay, and operating system thread, and you can create any number of your JDK thread. JDK thread means virtual threads. Okay, when your application want CPU execution, then they are mounted to any particular OS thread, and now your whatever the instruction written inside your thread they are doing. And let's say after some point of time they are going to wait IO call something. So complete this thread is unmounted. Unmounted and again go back to the heap memory. And now your stack operating system thread is free. Now you can associate another virtual thread. That means one operating system can run any number of virtual threads. Depend upon your virtual threads style of work. What the virtual thread is going to do. So let's some example. How I'm going to create virtual thread. Okay. So as simple as previously. Simply say thread class dot of virtual. Now you from please be note that now you cannot create virtual thread from your constructor of the thread class. You must use the some static method like of virtual. So you say a virtual and dot. Here we have a, you want to create virtual threads with unstarted or started. Let's say I want to unstarted, means I want to just pass your enable task. Oh, just okay. Whatever your task you have, just pass your enable task, and now you are getting the. So now this is the virtual thread. So now you have virtual threads. Now we have passed the runnable object. Now here simply virtual thread dot can start. Same either you know and virtual thread you can dot join. So there is a no any major syntax and semantic changes. Whatever the way you are creating a platform thread, similar way we are going to create a virtual thread and just run it. Okay. So now you are creating virtual thread and now your virtual thread and virtual threads can be run any your worker thread or you can say OS thread. Here internally virtual threads are implemented the concept of fork join concepts. Okay, and this fork join and a common pool fork join has something different, but surely that not the same. So please be note internally they are create some concept of fork joins where they are just uh, uh, pushing out mounting and unmounting your thread in a particular OS threads are implemented. Okay, so if you want to similar new way you can also create a, if you want to create a platform thread you just say I want to platform of platforms and just say this is a platform threads and similar way means ki now you can the same use the factory method for platform thread as well as. So very minimum changes as a Java designer did for our main library. Now you can create a same thread class using the virtual thread or same thread class is for creating a platform thread. Now this is a platform thread. Now notice this is your virtual thread. Platform threads you have created number of threads, but virtual thread you can create any number of threads. So let us also look like here. We can say like int stream. Let's int stream dot let's range, and I want to create a 1 to 100 and just mark map to object and just create your index number and here you can create the your thread dot let's create the platform thread first platform thread dot you can say pass your whatever the runnable task you have, right? And even you can say I want to create like a dot one another method like start virtual thread and just pass runnable. Here you are manually not going to, right? And dot just create a task map to object and just let's comment out dot dot collect to to list list. Directly that's a method. To list. And even let's do here something like of platform thread dot unstarted, just pass runnable, and now you have a header, and after that just say you have a list of threads, and here you can say just start all the uh, threads dot stream dot for each thread for thread oh, thread, let's d colon threads, and you can just I want to say just start and join. Here say t dot started, so all threads we started, and just say after just again so you can say just join to complete. So nothing, we are just doing here creating 100 threads, and that is platform threads, and after that all 100 threads we started and just waiting to complete. And even you can write something here as south, here say that's a return dot where, okay, thread return thread, and let's here just print if example I double equal to let's 0, let's say start from 0, just print is something they are printing as a south thread dot current thread. Okay, so here we are creating the 100 platform thread. Let's run it, and each threads are just taking a 2-minute break. So here your all the, let's here created your 100 threads. Okay, and similarly you can create a of virtual thread, and the same, there is no any code change, and you can create your list of virtual thread as well as just I'm just commented out. Okay, so now you have created a list of virtual threads. So there is no any major code changes, but surely there are, okay, and in this way your threads are done. Here you are creating your main threads, or even you can write complete instead of due to the lambda expression, even this code you can write instead of here itself, right here pass, and here you can write, okay, like just thread dot sleep, and sleep method also just overloaded and give it some duration. Usually you can just wait for 2 minutes. Try catch here and catch interrupted exception. So you are just created the list of virtual threads and just printing. So in this way you can create a huge number of let's instead of here just print it. Okay, so and even you can also write here also before and after. So means similar way we can, there is no any major changes, but yes, fundamentally behind the executions are changed. Now you notice we are creating virtual threads. You notice we are creating 100 thread, same for I equal to 0 and equal to 0. One times they are printing thread name one thread, and for this is the 5 threads. If you go to the either platform threads, you notice that key same threads are doing our complete runnable task. Here notice one sometimes they are first part are due by the worker thread 1 and next thread is due. So in this way you can say here the notice after waiting still our main thread doing. But in the case of so here example you can say this is like a even you can let's create a 1000 yeah 10,000 threads, right? So you can create any number of threads and each are waiting at two. Now we can create a 23 threads and still running. If you change here a virtual thread and you notice that same threads are one thread doing this part and another thread doing this part of your runnable jobs. So this is the demarcations of the virtual threads. Notice that the first part are done by your worker thread 1 and another part remaining part of this done by worker thread 7. Okay, even you can create more threads, what number of you want. So let's see how many number of in my laptop we can create it. Okay, good. Let's create further. So we created almost let's what happen. It will take some times and create it. That's one more time. But each times you notice that your first portion of threads are doing the same threads and the later portion of thread is doing by another threads, because we are creating a platform threads always bound to your operating systems. Just there are no any chance we can unmount or mounting. But in the case of your platform threads, virtual threads, we have options we can mount and unmount. So in this way you can also just use of the virtual threads whenever you want, whenever main purpose when you want our application server for each threads or each users are handled as separate threads. For those scenario this is really very useful concept. But underlying please note JDK threads also not, you can say, even uh, not run anywhere. For running, for executing your task, they need platform threads. So that is let's run how many times. Even you can calculate times and each and everything, but the concept is very simple. You can even create a simple thread class as a factory method of virtual of platform, or you can use thread dot start, or even you can use the executor framework to start your virtual threads, right? So here just of virtual, and you can create your virtual threads. So let's wait, code compiles and running. And now in the case of virtual threads, these logics are breaked. Some portions are done by the thread one, another depend with code level during time. So now use mention here. Okay. So here, so the the two scenario where virtual threads are cannot be unmounted. Unmounted means your OS threads and your list of your virtual threads, small threads, short-lived threads are going to mount in your operating systems and operating system running code, and once they are going to the waiting something, again this threads is unmounted to a heap memory. But two cases where your operating system threads cannot unmount your virtual threads. The case is that if your code are using the synchronized block. So if your code using the synchronized block, at that time your platform OS are executing some native code or any native methods or foreign functions. In those scenario, our virtual thread are cannot be unmounted to heap memory. So these are pinned to the OS. If our system identified if your thread are using any native call or any synchronized block, so for those virtual threads, they are bound to specific OS threads, and OS thread is work as platform thread. So please be know that this virtual thread might be not works for your synchronized block and any native calls, because here they are using some internally C call and some local stack frame. Those cannot be swept out from your platform thread to heap. So there are some might be in future release, but that will might be take a larger times to implement, and due to that, but there are some alternatives if you are using the synchronized code, because these are implemented in the native as a C language. Due to that, they are not unmounted, but alternatives suggested by your Java designer, you can use reentrant lock. When reentrant lock is implemented by Java itself, okay, so if your code is in the reentrant, at that times your virtual thread is easily mounted on a platform thread and unmounted on a platform thread any number of times. And this is the one major use case of reentrant lock. Sometime someone asks, I am using the synchronized block, why I can use reentrant? But now from a virtual thread concept, synchronize and reentrant lock play major different role. If your code is in synchronized block, in that case your virtual thread are cannot be unmounted or mounted. But in the case of reentrant lock, your code easily unmounted and mounted. That means कि your OS thread can be works for any number of virtual threads. So these are the two minor Drawback, please be note that while using the virtual threads, if your code is in a synchronized block or any native call, in those case virtual thread is not work, just work as a platform threads. If you want surely code refactoring for synchronized block, you can do the rendering block. So there are some differences about the platform and virtual threads, like as discussed, what the thread class currently have. The public constructor, you cannot create a virtual thread, and even virtual thread are always a daemon thread. That means they are running, maybe sometime running, sometime waiting, sometime running. And if this is so in the virtual thread, there is no any make sense. You can say set daemon true or false, because this method cannot do any change on your virtual thread. So thread dot set daemon is not many do any change in the virtual thread. And as you know, virtual threads have a fixed priority as a normal. Even you cannot change the priority of virtual thread. The virtual threads is always run on your normal priority. And even the virtual thread are not directly the active participation or your thread group class. And even such function like a thread.stop, suspend, resume, these methods are no any impact or no any meaning for the virtual thread. If you are going to invoke this function stop, suspend, resume, you get exception like throw exception. These methods throw exception when you invoke on a virtual thread. So these are some basic things we generally as a developer we are doing before virtual thread concept. Always you are creating a thread from thread constructor. So please be note that from thread constructor you cannot create any virtual thread, and even try to use the factory methods given by the JDK19. So if you want to create a virtual thread of virtual, you want to platform thread of platforms. So these are the summary. You can say virtual threads are kind of very cheap to create. Any number of virtual thread you can create, and even blocking virtual thread also cheap. That means whenever your thread is running, okay, virtual thread is running, now you can call one blocking call. Okay, so this is the previously your task is blocked and corresponding thread is blocked, but here your virtual thread if going to block, they are just push out, and now your thread, this thread is free to take another walks. So due to the virtual thread is very light, super lightweight, easy to create, there is no any make sense to create the pool of virtual threads. No need. As number of thread you needed, create a virtual thread. So there is no any use of your pooling virtual threads. So these are the some minor brief summary about your virtual threads. And as a programming perspective, there is as a code perspective, there is no any major changes, but there is different factory method given. If you want to get the benefit of want to create a many number of threads as number of your users, as number of your requests, please use the virtual thread. And here virtual threads offer you can utilize your CPU hardware as possible. Currently your CPU have a huge capacity to calculation, but we are requesting fixed number of threads, and due to all threads are waiting blocking something, our CPU are very less utilization. So in the case of huge number of you can create a virtual threads, huge number of virtual thread as number of your application request. There is no any limitation on your application. Currently at a time how many number of user requests, just create one virtual thread, and depend upon your server capacity. Our systems internally using the Fox join frameworks, they create your use the operating system threads, and any number of virtual threads are can run by any, maybe